Yeah, there's excitement. So there's a lot of people that have come from different places of the world, Australia for one. They put a lot of planning and effort into being here during the eclipse. NASA is here, they're in the park. They're gonna have tables available where they're doing arts and crafts and sharing information and doing some science projects. But they have a huge project that, the park staff here is taking part in, and that's the Soundscapes project. And they study the sounds of nature. There's a lot of people involved throughout the whole country. This is just one of the sites that's taking part in the Soundscapes. One of the things that was mentioned when we had meetings and classes on this is that there is to be an expected change just from observations that they've recorded, that a lot of the nature will go silent when the eclipse passes over its totality area when it gets dark. But in addition to that, they're trying to find out if the animals have, how far out they can sense that there's a change going on. In my mind, I think like sixth sense type of thing, right? Like some way to sense that something is different is happening. But again, I'm not on that level of scientific understanding as people of NASA, but it's still really interesting to be a part of.
I'm Kate Russo. I'm author, psychologist, and eclipse chaser, and founder of Being in the Shadow. We're at Garner State Park, and I have set up a solar eclipse village, which is very exciting because we have a number of people coming this weekend to experience the annular eclipse, and we are in the path of annularity here. And we're also in the path of totality for the eclipse next year in April 2024. So this is a premium spot for the eclipses, and that's why I'm here. I've come all the way from Australia. I've been working with this community, Uvalde County, to kind of make something very special happen. So there are two eclipses happening in the US within a period of 6 months. There is the total solar eclipse, which is happening next April. And this is what us eclipse chasers do. We chase total solar eclipses. And no matter where they are around the world, once every 18 months or so, I will be there. I will try not to miss a total solar eclipse. The one that we're having in October 14th is an annular solar eclipse. And this is when the moon is a little bit further away from the Earth, and so it doesn't completely cover the disk of the sun, and you're left with this ring of fire effect. And it's interesting. I've seen 2 annular solar eclipses, and it's almost like when you know what a total solar eclipse is like, and then you see an annular, it almost gets to the main show and then it stops, and you know that there is so much more. 99% of the whole experience is that more bit that you just don't have during an annular. So I personally don't chase annular eclipses, but there is a lot of interest in this annular eclipse because it's happening in the US, within 6 months of the total solar eclipse. And you have communities like here that you're in the eclipse crossroads, and that means that the path of annularity in October and the path of totality in April next year, we're in this unique spot where these paths intersect. So these communities are really lucky because you get to experience 2 solar eclipses within the path, within a short period of time. So I've chased this eclipse, and I know there are other people who are chasing, but it's important to understand that the total solar eclipse, that's when you get the really, really immense emotional responses, where everything happens above you, around you, and within you. For the annular, it's interesting. We start to see some little light effects. You might start to see some animal behavior, but it misses a lot of that energy. So I highly recommend trying to get into the path of totality, experiencing it for yourself, and then be prepared that you might then become a little bit like me, that you might end up chasing eclipses. And there are a large range of tools and resources around now that show us about, that give us all the information that we need about where the future paths are. There's interactive maps of the paths laid onto Google Maps. And so I spend a lot of my time just plotting and planning and scheming and looking at maps and figuring out where I'd like to go. And for each path of totality, it's a long, thin band over the surface of the Earth. And so we can choose where we're going to experience it. So the parts that we're in at the moment, Uvalde County, we're in the crossroads of the annular eclipse and the total solar eclipse paths. And that's unique because normally any one location has a total solar eclipse once in every 375 years on average. So what's unique about this region is that we're having to plan very short, rapid, big events in a very short period of time. But what's unique about the path here in Texas is that it goes over some really beautiful areas. This area in particular is, it's the ecological crossroads. You've got some amazing landscape, geography, the Edwards Plateau, you've got the birds, the bees, the bats, the butterfly migration comes through here. So I was really, really delighted to narrow in on this particular area. So eclipse chasing doesn't necessarily mean for me that you parachute in, you see the eclipse and then you go away. For me, it's about embedding in the communities, experiencing it, try to help communities understand that this is something that they can love and experience, and it's wonderful, and you want to share it with your family, and you will remember it for your life, you will. And so I like going into communities, sharing that passion and excitement, allowing them to understand that this is a big deal so that they're able to really appreciate it and prepare for it. And I get to share that with them, and I get to hear their stories about it afterwards. I feel really privileged to be able to do that.
I've worked at NASA headquarters for 25 years, been part of Living with the Star program, leading that, Heliophysics as an emerging new discipline, and I'm a program scientist, the Science Mission Directorate. A program scientist can do any number of things, right? So I'm here actually trying to promote the Heliophysics Big Year. And heliophysics big year, heliophysics is not a common vocabulary word like astrophysics, right? So we are celebrating heliophysics year starting with the annular eclipse on 14th of October and ending with one of our missions called Parker Solar Probe that is going to almost touch the sun, but be in the outer atmosphere of the sun that we can see during totality, and that happens end of December in 2024. So in between this time, we have annular solar eclipse, we have a total solar eclipse, whole host of missions launching, other operating missions, really giving us a view of the sun, but not just the sun and how it is connected to our planet and the impact of that. So there's just lots of reasons, but primarily to get everyone to know what we do and how important this is. We have Earth weather, terrestrial weather, but the science is meteorology. So something like that, we have something called space weather that is created by the sun, but the science is heliophysics. Heliophysics is a combination of few disciplines, but most importantly, astrophysics, like we are studying the sun as a star, helio. But heliophysics together means not just studying the sun, but sun's impact on life and society, on space weather, on other planets like Mars, or when we take our spacecraft into the interstellar medium, the Voyagers. That's all heliophysics. So it's the connectedness of sun. Solar eclipse is this amazing sort of cosmic event where the sun, moon, and earth come together and are perfectly aligned, perfectly in the same plane. And when the moon comes between sun and earth, then the moon actually casts a shadow on earth, and a very narrow focus shadow called the umbra. And that is the path of totality, where it has completely, the moon in the sky has completely blocked the visible disk of the sun. And that's when you get to experience, the minute totality happens, it won't happen during an annular eclipse, but it will happen on the eclipse of 8th April 2024. Instantaneously, it's like day goes away, night almost emerges, but it's not the same thing. And the outermost atmosphere of the sun becomes visible for a very short period of time. depending on the particular eclipse and where you are, and you see the corona. And I say that if you see that, it changes you. The number of minutes in the critical path of totality or annularity for each eclipse depend on the placement of the moon, sun, and earth. The longest totality that we can ever observe from our planet is of the order of 7 minutes and 30 seconds. And that's a rare event. So on the sun during annularity, and remember, you have to have glasses on during the whole phase tomorrow. You cannot look at the sun directly. And when you are looking at the sun through glasses, you're going to see really beautiful events, like these are called filaments and prominences and different shapes around the disk of the sun. These are structured by the magnetic field. If you're seeing through telescopes, you'll see this in red because it's a special kind of light that is emitted by hydrogen ionized atom. So it's going to be quite spectacular, but you can't look at it directly. But when we block the sun, it's going to be about 90% blocking of the sun. So you can imagine that's going to cut off sunlight, and that's going to reduce temperature here. It's going to change the light conditions, and animals start behaving differently. So there'll be different kind of sounds produced by crickets or other animals. And there are lots of students here who are studying this for the annular eclipse, and they're going to come back and study it for the totality, which is yet another level higher up. So there are, understanding the movement of sun, earth, and moon. It's basic geometry, it's celestial mechanics, but having kind of, system displaying that with, you can set this up. And a lot of these examples are on the NASA Citizen Science page or NASA Science Activation page, which kind of takes you step by step into giving you instructions on how to understand, the phases of eclipses or phases of the moon, because it's all about going around the sun, the moon going around Earth. Their orbits are inclined differently, and that's why we don't get a total solar eclipse, every new moon, because the moon is either above or below the plane of the sun and earth. That's kind of the first, if you're talking about eclipses. But then there are different ways of viewing eclipses, right? So you can't look at it directly, especially during annularity. So you can create pinhole projection. You can create, kind of with your fingers, you can create projection, and you can see the crescents on the ground. You can kind of, project kind of the phases of the eclipse, and you can just look at the tree leaves and you'll see crescents underneath. Looking at the shadows, they are just mesmerizing, very different from the ordinary shadows we see. I'm going to ask you to search NASA STEM eclipse, and you are going to get to those pages. We have STEM activation activities, kind of detailed description of that. We have citizen science where students can participate. This is globalizing science. And to really understand the basic geometry that people often don't know about, what happens, who is going around whom, what is the orientation and tilt. This will teach you about phases of lunar cycle. It will teach you about total solar eclipses or lunar eclipses. You can learn a lot. When you ask that question of me, I'd say, here I am. I came from India. I'm talking to you. So if you have that burning desire in you with the questions that you want answered, then you pursue that. You have to be tenacious. You can't give up. Lots of people will say lots of things. You can't do it. Oh, you were not cut out to do it. You have to persevere. And with that, we can get pretty much wherever we want to.
I am the acting chief of the Heliophysics and Planetary Science branch at NASA's Marshall Space Flight Center in Huntsville, Alabama. Observations of total solar eclipses are important to NASA because it allows us to see into the inner corona. We have spacecraft that view the sun 24/7. They're in orbit around Earth and in an orbit in between Earth and sun. But they use technology that creates an artificial eclipse. It's called an occulting disk. It's just a little disk that fits over the bright part of the sun and allows us to see the corona, the highest part of the sun's atmosphere. But during a total solar eclipse, we can see down in farther into the corona, and it helps us to connect what's going on the surface of the sun that we call the photosphere, through the chromosphere, and all the way up into the corona, the outer layer. Atmosphere has effects that go on that create, as a result of magnetic field, tension and then explosions. And these explosions can cause brightenings called flares that emit X-ray radiation, but they can also create coronal mass ejections. And the coronal mass ejections is just what it sounds like. It's an ejection of mass that travels into the realm of planets in the solar system, and it can affect Earth. So we want to be able to better understand the magnetic field associated with these events and predict them. We are a technological society, and as a result, we have multiple satellites in space, and the particles are traveling at very, very high rates of speed, which means they have a lot of momentum. So they can impact satellites that are in orbit, causing something called a single event upset, and give us erroneous data. They can affect GPS. They can even affect aircraft in our atmosphere, because the crew on board those aircraft get a dose of radiation. And also, they can cause effects on the ground. They can create something called a ground-induced current that can affect electrical systems and cause transformers to go awry. And the transformers are huge, and they take at least a year to replace and a lot of money. So if an event like that happens, it's possible that a community might be out of electricity for a year. Actually, one activity has to do with the moon. So there is an event coming up on the 21st of October called the International Observe the Moon Night, and that date changes just a little bit every year, but we celebrate it every year. And what we'd like for people to do is to start keeping a moon diary, beginning with the annular eclipse on October 14th. And we know that the moon's phase on October 14 will be new. So it'll be a new moon. And then a week later, it will be heading towards a quarter moon, when it's a quarter of the way around Earth in its orbit. So teachers could lead their students to keep moon diaries, beginning with October 14th and continuing on to IOMN, the International Observe the Moon Night, and then beyond, and then keep track of where the moon is and what its phase is. Why don't solar eclipses happen at every new moon is a great question. And it has to do with the orbit of the moon around Earth. There's a line, essentially, in between the sun and Earth. And we call that line the ecliptic. And the moon's orbit around Earth is tilted toward that line. So sometimes it's going to be a little bit above the Earth-Sun line, and sometimes it's going to be a little bit below the Earth-Sun line. And so the sun is still shining on the moon, and the moon is still casting a shadow, but that shadow is falling into space and not on Earth. And we don't experience a total solar eclipse every time, because the moon's shadow is so narrow, that path of totality is only like maybe 100 to 150 miles across. And most of Earth is water. So most of the time, that shadow is falling on water. And it's relatively rare that the shadow will fall on a landmass. And we're really, really lucky if we can get the shadow to fall on populated areas. If you want to be a NASA scientist, the best thing to do is have a curious mind. That is the number one trait. And the second thing is tenacity. And the third thing is take as much math in school as you possibly can. And the math and the science kind of go hand in hand. And don't try to focus on a particular field, because it'll kind of find you. And then when you find an interest, go after it with all the steam and muster you can amass.
I'm also going to be taking a group of hikers up to the top of Old Baldy. The elevation there is around 1,800 feet, and we'll be able to, see the eclipse from there. I'm really excited about the annular eclipse that's happening this weekend, and I'm excited about our total solar eclipse next April.
Thank you so much for watching our program. If you're wanting more programs like this, send us an email at distancelearning@tpwd.texas.gov. Subscribe to our channel to keep up to date with our videos we publish, and visit our website to learn more about our free educational resources. All information will be linked in the description.